When you use IP, a host, roughly speaking a machine attached to the network, is named by a 32-bit value. Now, most of what we're going to do today is actually assuming IPv4, which is the original IP protocol and the one that almost everything still runs on. When we write this 32-bit value, we write it as 4 8-bit values, each 8-bit value written as an unsigned integer, and then put dots in between them. So 155, 98, 111, 50, that is the name of some machine. It turns out this is lab1.eng.utah.edu. And then, of course, here's another IP address. So an IP address of that form names a particular host sitting on the network. If this machine knows that other machine's address, it can communicate with it. And the way it does so is it's not necessarily connected directly to that computer, of course. There's all sorts of computers in between that we call routers. So this router is responsible if this computer is trying to contact 129.10.116.81. The router's job is to decide whether to send information to that address here or here, and then this router will have to decide whether to go there or back that way. And eventually, if everything is working well, that information will get to this machine, right? Because the routers know which way to send things. A particular process resides on a host. So if this is a machine, there can be multiple processes, each trying to communicate with other processes over the network. For example, I might be running Firefox on this machine, so it's going to send information to some web server, like this one here, and it's going to do so by using a TCP channel that is identified not only by the host address, but also by a port number. So 7365 is a port number, and that combined with the fact that it's TCP identifies Firefox as a particular potential process that can receive responses back. The port numbers range, they're 16-bit values, so they range from 1 to 65,000 and some change. This same machine might be running some other program like NSLOOKUP. NSLOOKUP might, because it's using the DNS protocol, which is based on UDP, it turns out be on the same port number, but on UDP instead of TCP. This kind of collision doesn't happen often, but just be aware that it's the port plus the protocol that identifies a particular process's connection to the network. Meanwhile, if Firefox is trying to contact the web server over here, it will use not only this address, but also the port number 80, because 80 is the port number that's used by web servers. So the Apache web server would be listening for connections at port 80 using TCP. So if this Firefox over here is sending a request to this web server down in the bottom right, then it'll send a packet that starts out something like HTTP 1.1, and that packet will get combined with a header that says where it's supposed to go. So that header will say a particular host address, a particular port, and a particular protocol. And that way, as the packet gets sent to the routers, they'll know how to deliver it based on that sort of address that's stamped on it